Welcome to our presentation for DFT 170, Engineering Graphics, Semester Fall 2022. Our instructor was Dr. Hans Chapman.
So we did our SolidWorks design of an airplane propeller. This project was presented by Elliot Shanahan and James Nicholas. So here we have our RC airplane. These are just coming to the reference that we've done prior to SolidWorks here. So part one of our SolidWorks is the blade hub. So this part in particular sits in front of the RC airplane. This hub consists of multiple planes, and what we did was we pretty much had we used the circular option to make it actually round, and by extruding those cuts, as you can see on the top and the side, we can actually put those propellers inside the hub. Previously stated in the last slide, so these are the actual propellers that sit inside the blade hub. So these propellers, they sit at an actual angle for the wind pass through, and they're about 6 inches wide.
This is the nacelle. It is probably the bulk of the project and what took me the most time. It was created using so many different of the things we've learned. Lots of revolves and lots of shell options. It is what makes the propeller turn.
Part 4 of our SolidWorks project. So this is the main shaft. So this sits right in the middle of the nacelle when it's mirrored. Practically this is used for the connection of the ball bearings to the blade hub.
This is the ball bearing. I did not make this piece. I got it offline. I ran out of time and could not make it myself. It was honestly too complicated. This sits inside the slots in the nacelles and turns, so the blades and turns the main shift, and main shift turns them, and it turns the blade hub. This is the retaining ring. It sits at the very end of the main shaft to keep the front of the blade, to keep the blade hub from coming out. If you put any kind of pressure on the top of the blade hub, the retaining ring will keep it from just slipping right out.
This is our assembly for the propeller. So I guess you can tell the base of it, the nacelle, we mirrored it to where it looks like an actual full base now. And we went ahead and attached those propellers onto the blade hub.
This is my drawing document. It has orthographic and isometric views on it. It states that material is balsa wood, which is not something that I did in the assembly, but for my simulation I used balsa wood because our original idea was to make a model airplane, and balsa wood is very lightweight and very easy to cut out, and I feel like lots of model airplanes, wooden model airplanes especially, have been made out of balsa wood in the past. This is a simulation of one of the propellers. I fixed the endpoint that would be placed in the blade hub, and I put airflow pressure on the end of it, since that's where I feel like most would be coming from. And as you can see, the most stress is placed on the very base of the propeller, where most likely to break if you put tons of pressure on the end. Here's our animation. Here's our reflection. We spent lots of time brainstorming dimensions since we didn't have a physical item. We spent a lot of times on the actual plane that we did not end up using, seeing what dimensions we would need to make the propeller in order to fit in the front of our plane, or what size the wings needed to be in order to be bigger than the actual body. We spent a lot of time on design, and we learned a lot about working in a team and designing as a team and creating these dimensions while people are working on different projects at the same time. We needed to work on time management because we did not have a lot of time together to work on this and ended up doing most of it by ourselves. We really needed to work on communication and being able to email each other and let each other know what we've done. And we needed to set a realistic goal. I feel like what we decided as our project was a little bit too far out there and too big of a project, and we should have kept it simple and maybe just done the propeller from the get-go instead of trying to do the plane. Thank you.